Hi, and welcome back to the Reconciliation Project podcast, where we're formed by faith and informed by science. I'm Sam.
I'm Hunter.
And today we're actually going to be covering a little bit more regarding the fossil record. We actually had talked a little bit about the fossil record back in some earlier episodes, especially regarding Noah's flood and radiometric dating, in fact, but we will be discussing it a little bit more in detail today. We kind of have some starting questions that we kind of need to go over. Again, we've talked about this before, but there are things we kind of want to smooth out before we jump into today's episode. So first off, how do fossils form? We know fossils form very, very quickly. It's when a plant or an animal dies, sometimes things that aren't plant or animal. Sometimes we get tracks, sometimes we get dung, things like that. And it's when those things get buried very quickly under mud, sand, or volcanic ash, anything that's sedimentary based. But this has to happen before the organism or whatever it is rots away, decays, gets washed away, what have you. So this has to happen very, very quickly. Because of how quickly this has to happen and the conditions that have to be met, fossils are considered extremely rare. Now, we hear all the time about, oh, they found these dinosaurs, or they found whatever fossils. And that has kind of tapered off in recent years, but especially in previous years, there was almost an abundance of fossils. And especially if you go to a museum, it seems like there are hundreds and hundreds of fossils. So it's hard to think of them as rare. But given the conditions that need to be met to create a fossil, the fossil itself is practically created almost by luck in a lot of cases. So having them even at all is pretty significant.
And when you consider how many species there are, scientists estimate there's over 8 million different species. Those high numbers of fossils, because you got to consider that 8 million species is just what's living today. We don't know how many lived in the past. And fossils obviously tell us what lived in the past. Those high numbers of fossils, when compared to that big number of species we have, are pretty small comparatively. And that, like you said, is because of the extreme conditions required for fossilization to occur.
Absolutely. But to your point, fossils are considered to be kind of the zoo of the past, so to speak. You're seeing animals from ancient history, at least according to old Earth theories. A lot of what the fossil record is used to explain is evolution, and more macroevolution than microevolution. Not so much the speciation of, okay, we have one wolf and it's diverging into two populations of wolves that then become separate species. Not that kind of evolution, not microevolution. We're talking macroevolution on the scale of, oh, hippos and whales come from the same common ancestor, or every living thing comes from the same common ancestor believed to be a bacteria. That's kind of what the fossil record is used today as evidence for evolution. That said, we really need to talk about what we would expect to see if evolution were true regarding the fossil record, right? Do you want to jump into that?
Yeah. So what you would expect, and we do see some between species, but because of how rare fossils are, we're more likely than not going to find all those little intermediates between different species. But what we expect to see in any fossil that's showing change between one sort of organism to another is something that shows a particular part or structure that's altered in some way. That's different from life today, but is similar. Because we talked about last time with those homologous and analogous structures and all those fun things. We would expect to see those in these fossils. And when a fossil is found that has these similar looking structures, we call them transitional forms or transitional fossils. And as the name implies, it's a fossil that shows transition between what lived before and what's living today. Now, we don't always see something that's transitional from before to today. Sometimes it's stuff that lived far in the past. But these transitional fossils show us what we would expect if changes over time led to the formation of a new sort of organism.
And this differs mostly from what we would expect to see if species were created separately, as is discussed in the Bible with the creation account. What would we kind of expect to see there in that case?
Well, you have to really think about what your limits are there when you're talking about creation. There are some creationists who are very hardline, hey, evolution never happens, all of that science is a hoax, there's no speciation, nothing. And if that's the case, then we wouldn't see any sort of transition at all between any sort of organism. Plants, animals, nothing. We'd see no sorts of changes or transition. creation. On the other side of that, you have the other camp in creation that holds to God just using evolution as a mechanism to create, known as theistic evolution or progressive creation, depending on the specific beliefs, and we'll talk about those in a later episode. In that, we would expect to see a lot of transitional fossils of where God slowly made changes in life to give rise to new thing. And somewhere in the middle, you're going to have about where I reside with that. I think there are aspects of evolution that is undeniable fact. On the other side of it, there's things, the extrapolations of evolution that I disagree with and don't think are entirely scientific. But in that camp, you would expect to see some evidence of transition between one to another, but you wouldn't expect to see huge transitions such as links between marine life and land-dwelling life, which we're going to get into here in a little bit. So, like I said, it really depends on where you draw that line with evolution. Do you think evolution happens at all? Do you think it happens fully to the extent science says? Or so it really depends on what you in your worldview expect and what you think about this evolution science.
Now, you mentioned a second ago transitional forms. Can you talk a little bit more about what those are, maybe what some examples are?
Yeah, so like I said, they're just fossils that show change between two different organisms. And there's a lot of popular, quote unquote, transitional fossils. The first that gets talked about a lot is called Tiktaalik. And Tiktaalik is the thought transitional fossil showing the transition from fish with fins to land crawling creatures with legs. And what we see with Tiktaalik is some structures that do start to have some of those bones of a foot, but still largely is still fin-like. And what's thought with Tiktaalik is that this was a transition between a fish and I believe they go to amphibians, because amphibians live in both water and on land. But the idea is Tiktaalik is that first emergence of legs from aquatic creatures. And the interesting thing about Tiktaalik is when you look at the fossil, it's a very interesting looking fossil. I don't think we have anything alive today that really looks like what Tiktaalik looks like, but it looks kind of weird. It has a head that almost looks like an alligator. So picture the head of an alligator on a fish, pretty much. But some of the interesting things with Tiktaalik is when you look at those fins, they really look a lot more like a fin than they do a foot. They may have some differences, but as we talked about last episode, we know that some structures can have those similar appearances, but have completely different functions. So just because it has some more resemblance of a foot, not much, but a little bit, the conclusion then you draw is that actually the transition from fin to foot? Or is it just an adapted fin of some sort? Because there's no Tiktaalik alive today, so we really can't know exactly what it did. All we can do is make conclusions based on what we have, which is the fossils. And the other conclusion from that is, okay, it's just some sort of adapted fin for Tiktaalik to use.
Which, if you think about it, would actually be a huge advantage. In fact, there are many species of fish today that are considered fish. They're not considered amphibian. They're not considered a hybrid, but there are many species of fish that have very similar fin flipper type things that they use to move from one pond to another. So for example, if the current pond that they're in is drying up, they can wriggle through the mud and kind of hop their way over to another pond, assuming it's close. This happens with mud skippers, walking catfish, climbing perch, lungfish, even northern snakehead. This would be a huge advantage. So the fact that Tiktaalik may have had this would have been very helpful in terms of natural selection.
And it could very well be something that came as a result of challenges in its environment, and because it had that selective advantage given to it by having a more adapted fin, it's very possible that they had an overall advantage because they had this fin structure that's different from just a standard fish fin. Yeah. And like you said, we do see those slight changes in specific environments because, well, they need that ability to move. Another popular, or I guess famous is the right word, famous transitional form is that of Archaeopteryx, and that is the fossil thought to be the transition from dinosaurs to birds. The common scientific consensus is that modern day birds evolved from flying dinosaurs or dinosaurs with wings. And Archaeopteryx falls into the category of what they've now called feathered dinosaur. And that is what they think is what started giving rise to modern day birds and ultimately flight. But the interesting thing with Archaeopteryx is, while, like I said, the consensus in science is that that's a transition between dinosaurs and birds, there are some interesting things to consider with this fossil. Some studies have shown that the thought ancestors for Archaeopteryx, which would have been dinosaurs, some of those fossils have been found in rock layers in various parts of the world, and they're thought to be ancestors to this feathered dinosaur, Archaeopteryx. Some studies have actually shown that these ancestors of Archaeopteryx are actually younger than the fossils of Archaeopteryx, which is interesting. They can't be ancestors if they're younger than what was supposedly their descendant. One study in particular actually showed that they lived in rock layers that were 20 million years younger than Archaeopteryx. So from that, you have to ask the question, is this actually a transitional fossil, or is it just a very early bird that looks nothing like what we have today? Because as I mentioned before, I do think there are aspects of evolution that are 100% accurate, such as change over time. I wouldn't expect a bird from 4,000 years ago to look like it does today. You would expect birds to change over time, just like you would expect all life to change over time. I think humans in 4,000 years ago look different than they do today, just because the environment changes, people change, and evolution happens. And when you look at the fossil of Archaeopteryx, it does look very similar to, in terms of its structures, that of just birds. It doesn't really have much. I mean, it has some unique characteristics, but most of it, especially its wings, are pretty similar to just standard birds.
Absolutely. Now, that brings up the interesting point, though, that there is a disconnect, especially with you bringing up how ancestors, quote unquote, of the Archaeopteryx are potentially even 20 million years younger than the Archaeopteryx. That, again, brings in the old Earth perspective and the issues with radiometric dating, which we brought up in episode 6. So we talked about some of those issues. And especially if you subscribe to the idea of an old Earth, that's a little bit more doable and a little bit easier to wrap your mind around. That said, that becomes difficult when some scientists are saying, oh yes, these are the ancestors of Archaeopteryx, and others are saying, no, they're 20 million years younger. You do have the disconnect of, okay, is radiometric dating actually that accurate?
Yeah, I think that's definitely something to consider, but what I think is more interesting is the fact that even with these dating methods that they hold very close to, they're still finding some issues with these potential transitional form, especially with Archaeopteryx. And when you look at the fossil, like I said, it does kind of look like a dinosaurish type creature, but at the same time, if you look at the fossils of a bird, it kind of looks dinosaurish. But especially from the creation Christian side of it, we would put Archaeopteryx in with birds, a bird kind, versus with dinosaurs. And we know there were dinosaurs that flew, but those flying dinosaurs in the creation worldview did not give rise to modern birds. And honestly, I think on the evolution side of it, even on that, I don't think they think flying dinosaurs gave rise to modern birds, because there's a discussion of where did flight evolve, and we know there were dinosaurs that flew. So it's interesting. If flight already existed when dinosaurs were here, why then did evolution give rise to flight again through dinosaurs that did not fly? Why not take what was already there and just change into modern birds? I'm not the dinosaur expert, but it is interesting to think about, I think.
Now, you mentioned a minute ago how you think that humans look differently back 4,000 years ago than they do now. Are there human transitional forms?
According to mainstream science, yes. There's actually several. There's the most famous one that we'll get into in a little bit. But first, talking about humans, I'm sure we're all familiar with the mainstream belief, thought, or idea is that humans and monkeys both descended from the same ancestor. One thing that's commonly said about evolution is, oh, well, if evolution is true, then why are there still monkeys? Well, that's not what evolution says. Evolution says that monkeys and humans both descended from a single common ancestor that was ape-like, that had features of apes, but also walked upright like humans, had a skull shape that was like humans, teeth configurations also like humans. So it had similarities of both. Again, going back to transitional forms, having those characteristics of both things. But again, evolution does not say that humans evolved from monkeys. It says that humans and monkeys evolved from the same common ancestor. But we're talking about transitional forms. For a while, we actually didn't have any transitional forms for humans, supposed transitional forms, until some were ultimately discovered. The most famous, of course, is Lucy. That is a fossil of Australopithecus afarensis, and it is, like I said, one that they think walked upright, had a skull similar to that of humans, had more of a short stature, but the main thing is having that upright walking, because that's a feature that no other creature in the animal kingdom, for the most part, at least in mammals, does. Most mammals are quadrupeds, meaning they walk on four legs. Humans walking upright, and monkeys, we see in monkeys, chimps, all of those that would go into that other primate group, have some upright characteristics, but even then they still walk around on all fours a lot. Humans really are the only ones that primarily and solely walk on two legs, again, in the mammal group. So the idea is the common ancestor between humans and monkeys would have been primarily bipedal. And the interesting thing with Lucy is, throughout the Smithsonian Museum, again, pretty sure that's a replica, the Smithsonian in DC actually has a display of what bones were actually found of Lucy and what bones were molded, recreated in a separate discernible color. And what you notice when you look at this display is most of the skeleton is not there. Most of it was just recreated based on what they think a ancestor of humans and monkeys would have looked like. And they did have some bones to go off of, but not many. They really didn't have many bones to go off of. So what happened with Lucy, I think, is they had an idea of what a transitional form, common ancestor between humans and monkeys would have looked like. And they got some bones that sort of, in a way, fit that idea. And then they took that and ran with it, essentially, and made an overall skeleton based on those things. And here's the thing, and based on that view that humans and monkeys share a common ancestor, and from that they built Lucy. But like I said, when you look at that skeleton, there's a lot of mainly monkey things about it. There are some changes to it that in the scientific world indicates more bipedalism, and some of that change towards more of those human-like characteristics. But like I said, most of that skeleton was not there originally. It was mostly recreated. And when you actually look at some of the pelvis pieces, they're actually more ape-like. And it's not until you make adjustments to it that it becomes to look more human-like. And I'm not trying to say scientists just intentionally alter things to make it fit their view. Now, that does happen a lot. But for the most part, scientists do try to avoid that. But when a scientist has a belief about how something's supposed to look, or an assumption, a set of assumptions, especially a group of scientists have a set of assumptions that they go off of, typically they may make some alterations to their experiment. Like I said, there's nothing necessarily wrong with that, but you have to take that into consideration, that they, in their mind, had something that it was supposed to look like, and they made it fit that.
Mm-hmm. Absolutely. And again, not all scientists do that. Is that the majority of scientists based on their own bias? Yes, that happens with everyone. Bias is everywhere. Everyone has a worldview and a bias. That's just how we work.
Yeah.
That said, there are cases, documented cases, where fossils or bones have been filed or ground down to fit what a scientific team is hoping to achieve or see.
Yeah, we're actually going to get into that one here in a little bit. But overall, we do see cases where scientists will alter their data, their results, or something to make it fit what they want it to be. If you think about doing a jigsaw puzzle, you're working on it, you find that piece that you think goes somewhere and it doesn't. Most of the time, you say, okay, this piece doesn't fit here. Let me search for the right piece. But you have some people who will try to force that piece to fit, even though they know it doesn't. And sometimes it looks correct. It can look very correct, but that person knows that it's not correct. And when you look closely, you can also see that it's not correct. And again, I'm not trying to say that some scientists with Lucy created this huge misinformation that's just, I'm not saying that. But what I am saying is that certain assumptions went into Lucy, and you have to take those into consideration.
Mm-hmm. Even with your jigsaw puzzle example, that happens in science all the time. Now, to the degree that we're talking about, where evidence is altered to fit a perception, yes, that happens. And sometimes in ways that it shouldn't, but it does happen regularly in ways that are acceptable. What I mean by that is that in some cases, when you get scientific evidence, and say, for example, you've done the experiment before, and you know for a fact, okay, it should be in this range, or it should be here. If you don't see that happen in your new experiment, you're going to be suspicious and say, okay, well, what did I do wrong? Might make you redo the experiment, might make you recalibrate your tools, what have you. That's a normal way of adjusting to new evidence that may be incorrect. What we're referring to is taking evidence, and instead of taking it at face value, regardless of whether it is correct or not, trying to make it fit into a correct mold, which isn't something that should be happening in science. gets to this level.
A very, 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 very basic way of thinking about it is if you did a calculation on, we'll say a thermometer, not really a calculation, you just read your thermometer, and it read out 73.2 degrees Fahrenheit. But you think that it wasn't supposed to be that, and what's going to best fit your study is a temperature of 80 degrees Fahrenheit. So instead of putting down your 73 degrees Fahrenheit, that what you got in your reading, you actually put something more like 79.6 degrees Fahrenheit. So that fits more of what you think. Like that's the alteration of evidence and data that we're talking about. Changing something to make it fit. And like I said, with Lucy, there wasn't somebody who decided, let's trick the world with this. That's not the mindset. The mindset is, I expect this, therefore I'm going to make it fit this. It's not intended to be a huge trick and hoax. That's not what it is. It's scientists simply applying their assumptions, which again, assumptions aren't a bad thing necessarily, but again, as I said, you have to take that into consideration when looking at data.
Now, to your point, there have been hoaxes before, yes?
Yeah, there's two big ones. The first one is called Piltdown Man, and it was thought to be a missing link, quote unquote. A lot of times these transitional forms are referred to as missing links because a lot of them we don't have. We don't have a lot of the connections between one thing and another, but that's really more of a thing of fossilization being rare. At least for sure, that's what the scientific community will say to defend that. And we'll also argue just because we haven't found it doesn't mean it's not there. But with Piltdown Man, it was thought to be one of the missing links between humans and monkeys. However, what was found with it, discovered later that this Piltdown skull, it was found to be a hoax because they discovered that it was created by combining the cranium or the head bones of a human, the teeth of a chimp, and the jaw of an orangutan together into one thing. So what this was something that was just fabricated to look like what they expect a transitional form between humans and monkeys to be, or that common ancestor. Because finding that common ancestor would obviously support this idea that humans and monkeys are related evolutionarily. So, like I said, this is where you get to that danger of, this is what I expect, and so I'm going to make what I have fit that. And I would even defend whoever, I don't know the names of the people who were involved with Piltdown Man, but I would even argue that the people doing it maybe didn't intend to trick the world. Maybe they did. I don't know. But there is the side of it that they had an idea and they wanted to make what they have fit. But because of these combinations of things from different organisms, it is, as I said, has been confirmed to be a hoax. Odds are these scientists did know what they were doing, but I don't think they necessarily, I'm not saying for sure, but I think it is at least possible that they weren't necessarily trying to trick the world. Maybe they were, but at the very least, they knew what they were doing. And then another hoax, for lack of a better term, is Nebraska Man. And with that one is they just had a tooth, and from that tooth they extrapolated to the point of, we found a missing link between humans and monkeys.
Overall, I think both Piltdown Man and Nebraska Man, again, regardless of motives, we're not going to delve into motives. The makers of the Piltdown Man, I believe his name was Charles Dawson. Yes, was he known for planting fake discoveries? Yes. But he also died before any of this came to light that, this was a fabrication. So we don't really know his motives for sure. And I'm not sure that I fully understand the motives behind the Nebraska Man. But I think overall that proves more that scientists can be fooled by confirmation bias. And as much as many of them won't want to say so, very much want to claim.
Yeah, with Nebraska Man specifically, that was more of an incorrect identification of the teeth. Because what they said was that it was something that was similar to humans or monkeys, one of those two. But they actually found that those teeth didn't belong to either, or anything remotely similar, but was actually something else entirely. So Nebraska Man wasn't like a full recreation of like a skeleton. It was just something that was misidentified and extrapolated to the point of, hey, we found a missing link.
And again, that's confirmation bias. The idea that, I expect it to look this way, therefore, this must be this thing. That tends to happen a lot within the scientific community. It's something that the scientific community has to overcome, but it's common. It's something we can deal with, but it is incredibly common. That, coupled with scientists' propensity to want fame, to have their discoveries recognized, what have you, is a very dangerous combination.
And again, I think we can both agree, we're not trying to say that the scientific community intentionally is tricking people. What we are saying is that those confirmation biases and those assumptions drive what happens in science. Every scientist will have some sort of assumptions that they go into an experiment with. And if they expect something to come out that way, they're going to make that experiment as best as they can to achieve that result. And a lot of times in science, it's a bunch of failed experiments. Ask anybody, actually, don't ask somebody who's doing a PhD right now, if anybody that's doing one, how their experiments are going, because odds are they would be upset with you, and that would remind them of how other experiments are failing. That's the life of a PhD student, from what I hear. It's a life of failed experiments. Scientist designs an experiment to have a certain result, and it fails. And a lot of times that's just what happens, and they have to deal with that. But there are times where you get a result that was close and you make adjustments accordingly. And what happened with all of these is not some of it was just a completely failed experiment, and others we got results, but they're not quite right. But yeah, scientists aren't out to trick the world. But again, I'll say this constantly, everybody has assumptions, and everybody approaches everything with that base of assumption, and scientists do too. And those assumptions are going to color what happens in their experiments and in their study. And that's perfectly fine. There's nothing wrong with that. But you have to consider where those assumptions go, especially since we're dealing with a very sticky, heavy topic with evolution. It's a very contentious, is the right word, topic everywhere. So you really have to be careful with assumptions on both sides, because creationists are very guilty of making assumptions as well. And sometimes they make very bad assumptions. That really doesn't help the general view of the creation camp. So you really, really have to be careful with making assumptions and then what you do with them. You really have to be careful. So we're talking about all these transitional fossils. Let's go back to just the fossil record itself and talk about where in the fossil record we see the arising of life.
Absolutely. So a lot of what's considered to be the main basis of like diversification on Earth is the Cambrian explosion. Now, according to the old Earth model, it's believed to have happened over 500 million years ago, and it's categorized as a rapid evolutionary event, quote unquote. What that means is that it wasn't just boom, we suddenly have life all of a sudden. It is a showcasing that the majority of animal groups suddenly appear in the fossil record, and not overnight. The radiometric dating that has been done with the surrounding rock layers and other fossils surrounding these suddenly appearing fossils is anywhere from 13 to 25 million years that this explosion covers, right?
Yeah, and that sounds like a lot of time, but in light of evolutionary time or deep time with a 4.5 billion year timeline for Earth, that's really not a lot of time.
It's really not, no. So that's why it's considered a rapid evolutionary event. Now, we disagree with that timeline because we're young Earth creationists. We have issues with the fossil record in that sense because of their use of radiometric dating and the issues we have with radiometric dating. That's really what we need to bring into the equation here. If we have issues with radiometric dating where the math doesn't entirely work out, if the math is off and radiometric dating is wrong, that completely throws off the Cambrian explosion. Now, the Cambrian explosion isn't the only evolutionary event that's fairly rapid. There are others. It's the most well-known, and it's considered to be one of the fastest in terms of evolutionary time. But there are others. What we really need to discuss here is what does that mean for evolution if the radiometric dating is off, right? And then what does that look like from a creationist perspective? Creationists have come to the Cambrian explosion with the idea of, oh, it all appeared overnight and we don't know where it came from. Not entirely true. The idea of it is that the rock layers cover a fairly long span of time still. So it's not just an overnight phenomenon. That said, again, bringing us back to issues with radiometric dating, how do you combat that? For creationists, that means, again, targeting radiometric dating, getting that math nailed down and solid. Right now, that math is entirely based on whoever is doing it. Like we said, worldview plays a very large component into this. Now, that seems really odd because everyone thinks, oh, math is math. 2 + 2 = 4. That should be obvious. That's not the case with radiometric dating. Radiometric dating requires that an assumption is made based on when the expected date of deposit of either the rock, fossil, whatever you are testing, was laid down. If you assume that that time was billions of years ago, you're going to have a different result than if you assume it was 4,000 years ago, which becomes a very big issue. That's really the thing that creationists are dialing into, right? Is what's really going on with radiometric dating and how can we nail down that math? Because it's not. It is entirely dependent on what that prediction factor. So from the creationist point of view, many creationists still are trying to catch up to the idea that the Cambrian explosion wasn't necessarily overnight. The good ones are getting into the math, and that's really where the majority of us need to dial in. I would argue the majority of us need to dial into, particularly because of the issues with it. Does that mean that all of radiometric dating math is crappy and we should just throw it all away? No. There are very real mathematical models that are used. It needs perfecting, and it needs some work to get those numbers into a range that's actually doable. And that's going to ruffle a lot of feathers, especially in the older camp. Some people are not going to be happy about that. Anytime something goes against what somebody thinks is real, they're not happy about it. So we need to be doing this with love and respect, but it needs to be done.
Yeah, I would agree. I feel like the hard part on that is as soon as you challenge the models of radiometric dating, you inadvertently challenge evolution, because without all that time, evolution is impossible. I think any scientist would agree. Without all that time, evolution does not happen because it's not enough time.
Absolutely. And the problem with that too, though, is especially after Charles Darwin, the idea of evolution creating the full diversity of life that we see today on the level that it is described by neo-Darwinists, that gives people the license and the ability to have full autonomy over their lives and to completely dismiss the idea of any outside working force. You can do so without evolution. It's much easier with evolution. And that has made it very, very easy for evolution to become a god. You challenge someone's god, they ain't gonna be happy. And that's really where a lot of any transition that's made in radiometric dating, I think, is going to tie back to, but it has to be correct because it's my god.
That's where you get people like Richard Dawkins, famous atheist, saying evolution makes it possible to be an intellectually fulfilled atheist. Because without evolution, your only other option is a deity create. And I say a deity because almost every religion in the world says that there was a creator. I say almost because I'm sure there's several religions that say the universe is eternal and all that fun stuff. But most of them say there was a creator. Again, going back to evolution, the only alternative is you really only have two choices, creation or evolution. A lot of times we see, especially Christians, trying to combine the two together. And we'll get into that again in a later episode. But for the general public as a whole, evolution really has made atheism a lot more popular, I'm going to say. And I think that's because if you don't have evolution, let's just think for a minute that scientific community prove that creation happened. Let's just say they found something that 100% proved creation, which first of all, that would destroy evolution as a whole. So that gets rid of evolution. You'll still have people rejecting the fact there's a creator and a god, but it'll be much harder to do so. Mm-hmm. It would just be people who absolutely hate the idea of having a god and they just deny it just because they hate that idea. Because without evolution, that's really your only other choice, is a creator. But because evolution is there, it makes it a lot easier for people to say, oh, well, science says there is no need for God, therefore I'm not going to believe in God. And you really, that, as you said, it gives you more autonomy over yourself. Mm-hmm. Which, understandable, it feels good to have that full control over yourself. You don't want somebody being your boss. Makes sense. And again, going back to what we said before, I'm not saying the scientific community is out there trying to say, oh, we hate God, therefore we're going to disprove God with evolution. That's not what's happening. But especially going back to the roots of evolution with Darwin, you have scientists who didn't like the idea of God and were trying to find an escape.
And they jumped on when they found it.
When they found evolution, they jumped on it. Because Darwin, believe it or not, went to what you could consider a seminary. He was studying theology before he went on his trip on the Beagle as a naturalist. And in his view, the Earth was much older than they thought it was at the time. And in his opinion, he didn't fully agree with there being a God. And honestly, he didn't care for that idea. And as you said, he and other scientists jumped on that opportunity when they found an escape. And we see where that's led today. I've said this before and I'll say it again. The reason the world is so far from God today goes back to Darwin in 1859. Because without evolution, you have no other choice than to accept that there's a God. Either that or you're just denying the obvious. And you notice the script is kind of actually flipped. Atheists like Dawkins will say, you're just denying the obvious if you deny evolution and say that there's a God and a creator. I read a book recently, he actually had a quote on the back of that book where he pretty much said, hey, you don't agree with evolution, you're stupid. Pretty much, verbatim. And Dawkins is known for being pretty blunt and direct to the point of disliking people who are of faith. And he's actually drawn criticism even from his own scientific community and atheist community for being that direct for lack of a better term, and critical of people of faith. But I know other scientists do agree with that view that if you disagree with evolution, you're stupid. Bill Nye's one, and there's others as well. So like I said, that script has kind of flipped from before, like you had to believe in God or else you just look silly, to now, oh, you have to agree with evolution or you just look stupid. And ultimately, it really does go back to what you believe in your worldview. And you really, like I said, have to take all that into consideration when dealing with all of this. All right. I think that's going to wrap us up, though, for this episode. So thank you all for tuning in. For the next episode, we're going to be looking at specifically human origins. So we're going to continue looking at evolution, but we're going to look at human origins, the early forms of humans like Neanderthals, and some others as well. So really looking at where did we humans come from, and also talking about questions like, what about Adam and Eve? Like, were they real people? Were they not? Were they just representatives of a much larger community? Things like that. Thank you again for listening. We hope to have you back next time.